Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the question from the chapter atoms. Okay, so let's start the video. Question is, during the transition of electron from state A to state C of a Bohr atom, the wavelength of emitted radiation is 2000 angstrom and it becomes 6000 angstrom when the electron jumps from state B to state C. Then the wavelength of the radiation emitted during the transition of electron from state A to state B is how much here? Okay, so here in this question, remember that here the key word is emitted. What is going to happen? The photon is going to emit. In this chapter, when you will see the spectrum, so in a spectrum, what is there? When the electron will go from low energy state to the high energy state, there will be the absorption spectrum. And when it will come from high energy state to the low energy state, what will be there? In that situation, emission spectrum will be there. And here we are talking about the emission spectrum here. Okay, so here I have taken here the some levels. This is level of energy A, level of energy B, and level of energy C. Okay, so first we can see very well the transition is happening where to where? A to C. Okay, so when I will take here A to C, this is the energy transition is there, A to C. Let's take in this situation wavelength of the photon, what is there? Lambda AC. Okay, next one, what is given here? They are telling state B to C, state B to C. So when it is going state B to C, so let's take here what is given here? Lambda BC, that is here, what is there? 6000 angstrom. Next one, they are asking where to where? State A to B. So state A to B, what we can write here? Let's take here. So this one we have to calculate lambda AB. Now this is the basic. And if we talk about here the values and all that here, so remember that here, if we talk about here A to C, lambda AC is given here what? 2000 angstrom. Is it? And next one, if we talk about here, what they are telling here? B to C. So lambda BC, what is given here? 6000 angstrom is there. Okay, 6000 angstrom is there. And what we have to calculate according to the question, we have to calculate lambda AB. This is the situation. Okay, now after that, remember that here, as I told you, basic, this is the emission spectrum is there. So high energy minus low energy. Again, I'm telling you here, if we see in this way, what is there? The energy is decreasing here. Energy is what is happening? Energy is decreasing. This is high energy, this is low energy. Okay, so if we write here, basic high energy minus low energy is equal to h nu or hc by lambda. Okay, this is the basic. Okay, so from this basic only I will write here the further equations. So first equation I can write from A to C. Okay, so I can write here C, A at high energy, so EA minus EC is equal to HC by lambda AC. Is it? Similarly, after that, next one, if I write, A to C is given here, C, B to C. So B to C, what will happen that here? Can you write EB minus EC? Now, this one I am writing here, C, B to C. So EB minus EC will become here HC by lambda BC. Okay, and next one, if I talk about here, this one, what is given? We have to calculate A to B. So here I can write here, see, this EA minus EB is equal to what is given here, see, we can write here HC by lambda AB. Okay, so high energy minus low energy. Now, I hope so this is very, very clear. Now, as we have to calculate EA minus EB, we will just use here the little bit basics. So remember that here, as EA minus EB, EA minus EB, you can see very well available to us EA minus EC and EB minus EC. So EA minus EB, I can write here EA minus EC minus EB minus EC. Is it? Because when you will simplify this, anyhow, this is EA minus EB only. Okay. Now we can write here, see, what is EA minus EB? It is given by HC by lambda AB is equal to, what is this? HC by lambda AC minus HC by lambda BC. Is it? So both the sides, students, what will cancel out? This HC, this HC, this HC cancel. So we have got here one equation. Whenever the question is coming, this kind of question, we will always try to just use some common sense and make some equation so that we can just get it here. See, if we got this equation, that means our problem is solved. So now we can write here 1 by lambda AB that we have to calculate is equal to 1 by what is a lambda AC. You can see very well lambda AC is 2000, lambda BC is 6000. We'll put the value in angstrom only. Okay, so what is this here? This is the 2000 minus 1 by 6000 angstrom is there. Okay, answer will come even in angstrom. We should have the little bit knowledge of units and measurement also, so that we will not get confused in units. So here it will come here what? 6000 LCM. So 2000 and 6000, it will 6000 will cancel by 2000 3 times. So 3 minus it will go 1 time. So that I can write here, see, 2 by 6000. Okay, so after that we can write here, hence what is lambda AB? Lambda AB will become here what? 6000 by 2. So 6000 will by 2, what will become here? It will become here the 3000 angstrom. What is the answer? Can you see very well? The answer is 3000 angstrom. Okay. So which options are there? You can see the correct option is here. Option C is the answer. Is it? So students, I hope so. This JEE question is very, very clear to you based upon the both third postulate. Okay. Keep studying, keep growing.